Okay, so now we're ready to define a function. Let x and y be sets. A function from the set x into the set y is a non-empty relation which we will call f, which is a subset of the Cartesian product of x and y, satisfying the following properties. First, well, the order doesn't matter. These two properties have to be satisfied. For every element x in the set x, there exists an element y in the set y such that the ordered pair xy is in the function. 2, if the ordered pair xy is in the function and the ordered pair xz is in the function, then y is equal to z. The second element is going to have to be the same. In other words, we cannot map or pair uh, a given element in the first set with more than one element in the second set. So the set X is called the domain of the function f. The set y is called the codomain of the function f. And the range of the function f is the set, which we will denote Rng of f. And this is a set of all the elements y in the set y, the codomain, such that there exists an element x in the domain such that the ordered pair xy is in the function. In other words, the range is a subset of the codomain that contains all those elements in the codomain that were paired with an element in the domain. So another name for a function is a map or mapping. And this terminology gives us the ability to, this terminology suggests a way to visualize functions. So we'll look at a map diagram. So for a function, every element in the domain X must be paired or mapped to one of the elements in the set Y, the codomain. What is not permitted by the definition is that an element in the first set, the domain, be paired or mapped to more than one. We can only originate an arrow once from each of the points. So the element or the point x sub 1 can be paired with the point y sub 1, and it is fine that if that the point x sub 2 is also paired with the point y sub 1, and it is also permitted to that an element in the codomain is not paired with any of the elements in the domain. So some related notation. The notation f x right arrow y means f is a function from the set x into the set y. The notation f of x equals y means that the point or the ordered pair xy is in the function f. And we can also denote what happens with a particular point. We can say that a point x is mapped to the point y. So now let's talk about some important types of functions. So new definition. An injection or injective function is a function from some set x into the set y, where distinct points in the domain x are never mapped to the same point in the codomain. Y. That is, for every pair of distinct points, x sub 1 and x sub 2 in the domain, if f of x sub 1 is equal to f of x sub 2, then those points are not distinct. They must be the same element. So let's look at a map diagram. So in an injective function, an element in the domain cannot be mapped, or the elements in the domain cannot be mapped onto a common element in the codomain. Each one must be mapped to its own element in the codomain. But for an injection, it is permitted that an element in the codomain is not mapped onto by any of the elements in the domain. So new definition. A function f from x into y is a surjection or surjective function if every element in the codomain is mapped onto. That is, For every element y in the codomain y, there exists at least one element x in the domain such that f of x is equal to y. So let's look at a map diagram for this type of function. Oops. So for a surjective function, each of the elements in the codomain must be mapped onto by at least one of the elements in the domain X. So for surjection, it is permitted that two distinct elements in the domain are mapped onto a common element, but it must be true that each of the elements in the codomain is mapped onto by at least one of the elements in the domain. So, new definition. A function f from x into y is a bijection or bijective function if it is both injective and surjective. So quickly a map diagram for a bijection. For a bijection, it must be both an injection, which means each of the distinct elements in the domain are mapped to distinct elements in the codomain, and every element in the codomain must be mapped onto by at least one of the elements in the domain. This actually causes a restriction that there is a one-to-one correspondence between the elements in the domain with the elements in the codomain. Again, each of the distinct elements in the domain are mapped onto a distinct element in the codomain, and every element in the codomain is mapped onto by an element in the domain. So now we can define a transformation. A transformation on a set X is a bijective function or a bijection, which we'll call f, mapping x into itself. So for a transformation or for a bijective function in general, what can be done can be undone. That is, for every bijective function, that function has an inverse. So for example, if we look at the inverse to this map, we have the set y being mapped into the set x, where the point y sub 1 is mapped to x sub 2, and the point y sub 2 is mapped to the point x sub 3, and the point y sub 3 is mapped to the point x sub 1. So a transformation on a set X is a rearrangement of the points of X So one of the simplest types of transformations is a translation, that is, moving all points in some given direction. So let's look at what happens with an individual point, xy. That point is going to be translated to a new point, x prime, y prime. So using the language of vectors, we say that there is some vector v, and that vector can be described as x prime minus x for the first component and y prime minus y for the second component. But we may also know, or will also know, that this translation from the point xy to the point x prime, y prime required moving in the horizontal direction a units and in the vertical direction b units, so that the vector is also the vector a b. And so these two are equal. We have that x prime minus x is equal to a. The components are equal, and so y prime minus y must be b. And so the translation can be described in terms of the points, where the new points, xy, or x prime, y prime, is given by x plus a and y plus b.